Hey guys, Jim Vanosky with Manufacturing Talks. Got a really interesting and informative show for you today. I've got Adam Gluck. He is the founder and CEO of a company called Copia Automation here, and he's going to talk to us about industrial programming and automation and some of the challenges with downtime and troubleshooting, what that costs. We're going to talk cybersecurity, which is huge in manufacturing today, and just go over some of the kind of evolution of industrial automation that has made things challenging and yet, given us a lot of huge opportunities. So Adam is a guru on this stuff and he's here with us in about 30 seconds. So stay tuned here on Manufacturing Talks.
Welcome to Manufacturing Talks with Jim Vanosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Hey, everybody. Welcome back to Manufacturing Talks. I am Jim Vanosky, your host. We've got a really intriguing show for you today. It's all about a company called Copia Automation. I've got their CEO and founder, Adam Gluck, with me today. Welcome, Adam.
Hey, thanks for having me. Happy to be here.
Thanks for being with us.
Yeah.
So this one to me is really hitting a subject that I think a lot of people are thinking about around industrial automation and cybersecurity and causes of downtime. There's so much to dig into here for my manufacturing audience. But before we do that, I want to know what got you to doing what you're doing and what prompted you to found Copia Automation.
Yeah, absolutely. So I started my career actually at Uber. I
Cool.
most recently while I was there was working on engineering strategy, so kind of focused on the overall, actually back-end systems architecture at Uber. Before that, I was working on the driver product, which is very much just like, when you get into a car, what the driver's using there. Focus on the core trip flow. So uptime was super critical. My whole time at Uber, I was really focused on DevOps, and part of why I joined Uber to begin with was kind of the bits and atoms. So, working on a pure software solution, but you were also moving cars around the real world and kind of fixing logistics, all this stuff. So always kind of this interest in, what actually drives the economy, what actually drives things around, and industrial automation kind of fits that mold. And so I'd been looking into robotics and all this stuff for a while. And I, had different ideas of building a plant, actually building a factory, finding some industrial vertical, to reshore or something like that, that's more efficient to be local and all that stuff. And then, as part of kind of that research over the years, I kind of dug into the industrial automation stack and discovered everything that we work with every day. And I kind of this feeling of like, well, it seems like, it's missing all the stuff that had been in the IT space, in the software space of DevOps, which was actually quite new, which I didn't realize was only like 10 years old when I was like looking into it. And, initially 2018, 2019, DevOps was around, but we'd been using it all the time at Uber and Google and those sorts of companies all use that stack. So I was like, well, hey, can we bring that from the software space and make it work for this kind of core technology that like kind of made sense to me intuitively? And then I started talking to people, and I was like, well, why is this missing? Do you guys know about this in the DevOps space? If there's something better that's happening in the industrial space, came up time. It's like, well, we don't know why this doesn't exist in industrial automation. You know what I mean? So that was kind of the product market fit signal where it's like, yeah, we know what this exists in this other space. It doesn't exist here now. We want it to exist, but there's not a vendor who sells it. So that was kind of the initial piece of kind of coming into this. And, the rest is, kind of history since from there. So.
Got it. So when did you found Copia?
Copia was formally founded in 2020. I started working on it in 2019. I signed all the papers with Uber on the IP, so that's cool. But so that's cool. But I started working on 2019, kind of on the side, and so that's when I started talking to customers, that sort of thing. Immediately saw, I think of the first 5 companies we talked to, like 3 of them were like, this makes sense. And some of those people are still customers today. So it was kind of one of those things where it's like there was immediate interest in what we were doing, and we could find design partners, and people picked up our call. So we knew we were kind of onto something. And so I started working then in 2019, and then I actually quit Uber in June 2020. In July 2020, and start working on this full time then.
Got it. Okay. And you've kind of given us a few nuggets there on what inspired you, but specifically now, Copia Automation, what are you bringing to the industrial world?
Yeah. So, I mean, we describe what we do through the lens of, the phrase industrial DevOps. And that's kind of a phrase we've pioneered over the last 4 years. We see it's getting picked up now by analysts and that sort of thing. And there's some great reports coming on about it. And we published the first State of Industrial DevOps report. And it's a term that's starting to get used a lot more. But when we were kind of coming in the space, the idea was industrial DevOps. And there's a very clear vision for me, at least, that we've just been executing piecemeal for 4 years now. And it starts with, and I think the best way to look at DevOps, actually, and this way I start describing it to make it really clear to people, is like you finish coding in your environment, then there's a bunch of steps you should be doing before something goes into production. And in DevOps, and the way that we talk about it for industrial DevOps, is the steps from I finished my coding, how does this get onto a machine, and how do we know it works when it gets there, right? Another way of looking at it is sometimes people make changes and they break things. So we want to make process to prevent things from breaking, right? And then those kind of 4 steps that I always highlight, and this is how every single software business in the world runs. Every single critical piece of software in the world follows essentially these 4 exact steps. It's completely missing for all industrial code, which is kind of crazy, right? Given the scale of production there. But before code goes into production, Git-based source control with code review. You have someone review every single piece of code that goes into production. You can't approve or merge a change unless it's reviewed. Automated testing, that's a unit test, but you also have integration tests, that sort of thing. In industrial world, there are unit testing frameworks now. There weren't really 4 years ago, coming out from major vendors, emulators, sims. Actually, when we start Copia, people are like, why would I test some of the logic of my code? It just matters if it works in production. It's like that shift has already started to happen where people get why you test your code. Deployment. How's your code get into production? We've talked to companies where their deployment processes are so painful and so expensive to make a change in production that they actually just don't make changes that often. They'll write a bunch of code and not even deploy those changes. So like, what are the processes to actually deploy the code? How do you gate that? How do you, queue up changes so they can get deployed there? And then monitoring. SCADA has been around for a long time. Obviously, and we do have monitoring and alarming in these environments. You need that, but how do you integrate that into a workflow so that you deploy a change, an alarm goes off, you roll back, right? It sounds simple, but that's almost impossible to do given the current framework of industrial production. So this kind of those 4 buckets: source control, testing, deployment, monitoring, and then your code's on the device, right? So that's kind of how we look at it. And then our goal is to work with existing vendors and kind of merge their existing tooling and where possible into that workflow, and then kind of provide that kind of those rails for customers, and then that's the core thing. And then you see various degrees of adoption on that. So that's the vision. And then in terms of where our product is today, it's very focused on the source control piece. And then we have a product called Device Link, where we connect to physical devices and do backup on them. The reason we do backup, even though it's like a little bit separate from that vision, is that's where the space is today. So you go to a company and they often pull us and they say, we care about industrial DevOps, sounds really exciting, but we can't recover if there is a disaster. So that can be an IT cyber issue. That can be a literal disaster. I mean, you have places where you have weather shelters and industrial sites that might get hit by a tornado or lightning. Yep. I've seen cases of outages. They're just like, we're just hit with inclement weather, and our whole site, PLCs got fried as a function of that, get crazy stuff like that. Heat, heavy machinery, you get devices straight. So disaster recovery is bigger than just pure cybersecurity, but you see operational disaster recovery, and people just want to make sure those backups are there. And so that tends to be step 1 for sustainment, maintaining a plant type persona. And then you say, well, it's great to recover from a disaster. It's good to catch these things up. Can you prevent issues from happening? And that becomes the beginning of the industrial DevOps story. And then you move from source control to testing to all this stuff I talk about. But we try and match the industry where it's at right now in terms of what they need.
Yeah, and I find this all fascinating. I'm sitting here thinking back through my many years in manufacturing out on the floor, and it's always intriguing to me, and you kind of just illuminated what led to this, how every plant has a guy out there with a laptop correcting things in the code pretty much full time.
Yeah.
Right. I don't have to do that with my Excel spreadsheet. I don't have to have a guy fixing the code there. So I think you got into like, there's this missing element of DevOps in the
Yeah.
industrial world. Why would that be? Why would we have taken such a different course in industrial software and programming?
Yeah, it's super interesting. I think there's a few tailwinds, and I think the why now for any startup is actually a question that a lot of founders hate when VCs ask them. But I think like if you think that generally industries are, I tend to have the model of like generally speaking, industries are pretty efficient. Unless you
Yeah.
have something going into place that's making it less efficient, you have to assume if you have an idea, you should be answering why haven't they done this already? Because most people are smart and competent, especially when you get engineering orgs running critical production. So they're going to do things that are smart and competent and make sense 90% of the time. You can argue culture in certain businesses are more conservative or whatever, but if something makes sense, people are going to do it, generally speaking, right? And so when you take that lens, you have to then ask exactly yes, like why now, right? Like why weren't we doing this? So I think there's a few things. One, DevOps is a set of practices in software is actually not that old, right? It kind of really started in 2008, right? So if you look at that's like a 10-year-old, set of practices by the time we start talking about industrials, which is 2019, right? So it's like, okay, well, that's a little bit slower, but like on the scale of industry, it's not insanely slow. I mean, there's people with like 30-year devices that have been sitting around for 30 years in their plants, so it's like, in that world, the adoption is relatively fast. But outside of that, I think you look at a few things. One is there's a lot more automation. There's a lot
Sure.
more
Yeah.
code in an industrial site. And so, the end result of that is that the problem is a bigger problem. So if
Yeah.
you look at, an industrial site in 2008, what fraction of their outages do we think were related to code changes versus a highly automated site in 2024, where they have 100, 150 devices, they have sensors everywhere, PLCs everywhere, all of that stuff. So when you look at that, then you're like, well, actually now the problem exists. On top of that, there's other technology that needed to be adopted before you could really look at a solution like ours. One of the big ones is industrial networking. So a lot of the 2010s were like, you have to network these industrial plants that can exist anywhere, in the world, and actually get the kind of infrastructure in place, comfort with cloud and security and all that stuff. So I think there's a set of things, you have the whole set of network monitoring solutions, all that stuff. So like Clarity and Nozomi and all those guys. So, when you look at that, there's like some set of technologies that need to be adopted, I think, before you could build a solution like this. And then, on top of that, the problem needed to exist as a reasonable enough scope that people actually cared about it, which is kind of this piece. And then the third is like our solution is multi-vendor. And so you also see this like set of solutions in that people use. So if you're looking at, I need to manage all my code on my plant, no single vendor could build that. I mean, for example, see like Rockwell and Fanuc often deploy together, use Rockwell for your PLCs. You can see sites that are like Cognex, Rockwell, Fanuc stack, or Keyence, but you end up seeing that like all of these different devices are getting used in this environment, and they all, if any individual vendor built what we were building, then it wouldn't work because it doesn't capture the whole multi-vendor kind of matrix there.
Yeah.
And so you basically needed a solution like ours, a multi-vendor. So I'd say there's like a set of tailwinds in increased automation, a recognition of the problem, infrastructure that need to be in place. And then finally, you have multi-vendor environments. You needed a kind of third-party vendor to build something like this. And we pull all that together, then you're like, that's why this company didn't exist before, right? Because you had to have all those things kind of land.
Yeah. Well, that's intriguing. You called something out that hadn't really occurred to me is, you go back to the origins of automation and manufacturing, and we were really just adding some rudimentary brains to what were completely mechanical machines at the start. And then over time, we've gone to everything from, servo motors with higher level programming in the motors themselves, all the kinds of electronics, sensors, all of this stuff that's kind of been added on to that original way of controlling mechanical machines. And I can see where, that could create some problems.
Yeah, and it's kind of fun because if you go to a trade show, you can still see it. So it's not like we're out of that either. So
Right.
like you'll go to a
Yep.
trade show and sometimes interesting, like there's really cool, like I don't know what this actual device is called, but I saw this, I always think about this for some reason where like there's this it's like basically like a large kind of like curved thing like goes like this, it's like kind of, and they'll take that and the space in a way that just separates objects on a line.
Yeah.
For like beverages and that sort of
Yep.
thing. I should know what it's called, but I don't. And so it's interesting is you go look with those like highly mechanical, you build it for a particular use case, extremely effective, right? It just does its job. It's like, you're separating out these devices over and over again, it just does it infinitely. But then you can go sit next to that at a trade show and you'll see a robot that is like 4 arms and it's separating it, right? And it's an interesting question. I think it's actually a real engineering question of like, do you need the 4-armed robot? Or if you're always going to need this amount of space on this line, do you want to have the mechanical thing that just works all the time?
Right.
And I think
Yeah,
what we've
great
seen is,
point.
SKU shift and all this stuff. And so the flexibility of manufacturing has become more important, or maybe it was always important, but more achievable now. And then, as a result of that, people want to have a software solution. Software is soft, right? So you want something that you're going to be changing if it's going to be in software. And so the people are seeing that need for flexibility. I think, the programmability is important, and people want to optimize their lines and do all that stuff. So being like, let's pick a mechanical solution that we're kind of stuck with, and it's expensive to change, versus a software solution where you can tweak some configurations and formulas. I think there's a obviously push towards that as well. But it's interesting because they both still exist, and you can
Yeah.
see them next to each other if you go to a trade show.
Yeah.
Like the same problem being solved in entirely different ways,
Yep.
next to each other.
Yeah, another great point. And I would submit as a manufacturing guy that simple is going to be better and easier to deal with. So if you don't need the complex modern solution, go with the old mechanical solution. That being said, there are good reasons for going to robots doing things that we used to have mechanical machines doing. And
Yeah.
so even understanding that need and how to deploy it, I think is probably, part of the challenge and then part of the problem. But
Yeah.
then, as an old manufacturing guy who now is at least relatively technologically savvy, what I look at is we've still got this very non-user friendly, non-intuitive um, program and interface world on the plant floor. And meanwhile, I've got my phone with its apps where I can just very intuitively do anything, in the smartphone world. Why is there that disconnect?
Yeah, it's super interesting. I mean, obviously for our product, we do try and center user experience, and we're still, like, I think compared to a lot of manufacturing vendors, we're more of a Silicon Valley-esque company, right? In the sense that,
Yeah,
I mean, we're in New York and have people all over North America. We don't even have that many people in San Francisco, but it's still that kind of more of a startup energy, and we do have that kind of user-centric. Our head of product is ex-Apple, ex-Microsoft, so that user-centric kind of mentality
yeah,
in terms of how we build, and we care about that a lot. But you do run into, when you're building a tool versus like an iPhone app, that you run into material requirements. I had a friend who always talked about software. You can't abstract away reality too much. You know what I mean? So like,
yeah,
for example, you run into the complexity of the environment that you're building for, the variety of vendors that are there, and you can try and build as intuitive an interface as possible. Sometimes you're like, this is a tool, you know what I mean? And the tool
yeah,
does a set of things. And so we often, like, early in the company, we're like, are we building an iPhone app, or are we building surgical instrument? And you're like, if you have a surgical instrument, it's going to be more complicated and you need some training for it. Or are you building a tool? And so I think there's analogs in this in like the IT DevOps world too. Like Kubernetes, is the amazing, powerful framework. We use it for a bunch of stuff. We're a huge Kubernetes shop in that way, because we need to support all these different cloud deployments and all this stuff, and it makes our world easier. So we have material reasons why we need a complex solution like that, but it's a complicated solution. And people often talk about that as like a hard learning curve. Not in our business. People are used to it now, but it's not an easy learning curve to figure out how to adopt Kubernetes or Docker or some of these DevOps tools that have been really powerful. So I do think it's like, at the end of the day, it's a tool, and then when you're building a tool, you have to deal with the material complexity of where you're building for. Now, could you build more intuitive interfaces and improve? I'm sure there's areas for improvement, you know what I mean? But I
yeah,
do, you still have that material requirement, to in the complexity of the environment that you're building for.
yeah. Well, and very good point about the inherent complexities in manufacturing. You're dealing with machines themselves, you're dealing with the materials that they're handling, which can vary themselves, and then all the requirements of hitting the final product uh, specifications and quality specifications, all these things. So, yeah, people don't think about the enormous amount of complexity that goes into dealing with that real world stuff. Now, you referred to Copia's State of Industrial DevOps report, and I was looking at that. It really pops through how much time is spent and how much money is lost when it comes to coding errors and cybersecurity breaches. Um, what are you guys doing to tackle all that?
Yeah. Yeah, it's kind of interesting. It's where there's a phrase that we've sometimes, I don't know how much we actually use it from times. There used to be a phrase called shadow IT. And the shadow IT idea was like, you don't know who's touching your software, right?
Mm,
So there's changes happening in your software stack and your IT configurations that you have no visibility into. And I think one of the things that came out most strongly to me in this report was this kind of shadow OT, almost like especially the data point on like number of ad hoc changes, which I've also back verified when we have more detailed customer data. We've seen this. There's a huge number of just config changes in these environments, and the way that people report in an outage report or something like the PLC stopped working. And it's like, well, what, I've seen reports too where people are trying to like check people. They're like, the PLC stopped working. It was in program mode for some reason. You know what I mean? It's like, yeah, someone made a change, but it's hard to debug this. And there's kind of a constant issue of like, hey, like, is this a mechanical issue because these issues manifest mechanically, or is this a software issue? And then you get in controls engineers are like, we're always being blamed, and everyone's like controls engineer. So you get in this kind of like even cultural thing there. But just that's called the problem of like there are changes, and it's hard to understand the degree to which and this is why I was excited about the report is we started to get a little bit of a data point, that people are seeing that there's a lot of these changes to this environment. Because when we started with Copia, people were like, well, how much do people change this code anyway? And the reality is you have a lot of it and it runs most of production, so people are changing it a lot. You know what I mean? And so they do change a lot. Okay, so that's the first piece, and that causes a lot of these outages. So that's the scope of the problem is how do we fix it? Again, it comes down to that, well, you need to standardize. If you're going to have a software-driven environment, you need to standardize how software changes get made. And there wasn't maybe a reason to do that before if you're just making a few changes and you just have a few devices. But by the time you have fleets of, we talked to plants that have 700 PLCs, 1,000 robots, those are obviously bigger automation deployments. But if you're going to be changing things a lot, you got to have a process in place. And that's DevOps, developer operations. It's the operations of how you make changes in these environments. And so ideally, people are doing that. Now, what we see in the space is just scoping out the problem is important, which is why we have our automated backup solution, which also gives you a nice dashboard. We just did product announcement on this, but it's been there for a while, is like telling you there's all these unauthorized changes happening. So you're like, oh, wow, there are these changes happening. Like we actually see the problem exists. And then you start saying, well, let's adopt source control, and let's start building some process in place, and let's make sure people are actually, recording the changes they make. And then you're getting rid of those ad hoc changes. Ideally is kind of the first step there. And then you're doing process, and then you start investing in that process, right? It's like, oh, we missed this in code review. Well, do we have automated testing, right? So there's a story from just recognizing the problem, with automated backup and all this stuff to now we've solved the problem fully by having a set of processes for how we actually make changes safely in this environment, right? And then you do process investment.
Got it. Yeah, the standardization piece that is critical. And you reminded me of another thing from years ago where we had a technician who worked in one of my factories with General Mills who had been very educated in PLC programming and affiliated computer work. And anytime there was a problem in the process, he'd be out there making changes to the PLC program. It's like, nothing changed in the program. Why do we have to change the program to fix that problem? But, I guess you have a hammer, everything looks like a nail, right?
And it goes both ways. I mean, that's a very common issue is you just like, the stereotypes are always like night shift, but it's like something breaks, electrically or mechanically, and then you figure out a workaround on the PLC. And then, it breaks something else in 3 days, but then you're like, well, why is this motor running hot, or whatever, because someone changed the config or whatever. So you start to run into those things. And you see it in both directions there. Right. So,
Well, another topic that came up in your report is one that everybody's talking about, and I think a lot of people are scratching in their heads about, and that is cybersecurity. So what should manufacturers be thinking about and doing when it comes to cybersecurity?
Yeah, I see this as like a kind of a continuation of a set of trends that have been happening over the last 15 years. I mean, the whole interesting thing, and I mean, this is around when Industry 4.0 as a term came about, but you kind of saw this, and obviously factories have been networked for a long time, but if you look at the 2010s, I think they were very defined by pull data out of the environment, network every device, get everything connected, and people were doing this. I remember sitting at a talk with someone who's like, we're doing this project, and they like the whole only key OKR, the only key result for them was like connect more devices. And so they're just doing it quarter after quarter. They'd be like reporting up their VPs, every quarter and say we connected 5% more devices, 5% more, even 10%. And then the VPs are like, well, why are we doing this? You know what I mean? And so you kind of get this interesting, but there's this push to connect these devices. Then on top of that, you go like, okay, now we have this kind of network infrastructure at these plants. Let's invest in observability of that networking infrastructure. And you see a whole set of startups that kind of came out to solve that problem, which I think is like Nozomi, Clarity, Dragos, basically trying to solve like, hey, we have this network now that you can connect to and anyone can push a change there. Okay, well, we need to lock down the OT network. Now in the 2020s, we've seen this like IT, OT convergence. And so you get the CIO or the CISO taking over all these plants, right? Because now the architecture of the plant looks more similar to the architecture in the corporate network. So then they take over the plants because they're like, well, you guys managed to make sure we don't mess things up in the networks. Just take this over. So then they give the CIO and the CISO, and they go, whoa, we thought we had locked down our networks. We thought we were so secure. Well, anyone can connect to these plants and they can do whatever they want. Like, that's crazy. And so now CIOs and CISOs are coming in and they're trying to say, well, how do we actually lock down these plants? You know what I mean? They're looking at it, and then from there, but the benefit of that is they're also the more cloud comfortable, right? Because they've kind of adopted cloud over the last 15 years. So now you get this interesting question of, it's almost this next step of like, now we have a plant connectivity and with the OT network security, but now OT is kind of coming into IT, and we're now looking at this kind of networked, data pulling data out of these environments, connectivity, and can we bring this data and put into the cloud? And even in the last year or two, the shift towards cloud comfort as a function that has been really interesting. So you run into that. Tied to that, though, is again this question of like, we often get pulled into these disaster recovery discussions. So you also say, hey, well, when you look at DevOps, you're like, well, who can touch this code? What's an authorized change? Do we have a change log of changes in these environments? So you start looking at, literally billions of dollars of infrastructure at major industrial companies that essentially anyone connected to the network can change. Yeah. And there's no observability, there's no process. It's an insane governance and control problem that exists globally at every single one of these industries. And the best companies in the world are already on top of it. They recognize the problem, they're fixing it fast. You know what I mean? And then you get people who don't get it, or they don't get why they should have change management, or you get resistance at the plant level from people who are like, well, I've been doing this way forever. And you have to teach them the culture of cybersecurity, which happened in the IT space, or teach them why they need to have source control for disaster recovery. I have an old mentor who was at Microsoft in the 2000s, and I asked how to get adopted at Microsoft, and it was the same problem. People didn't get why it was valuable. And then he said, shit broke. That was his answer. So like, it's basically things broke, you know what I mean? So you run into this environment where it's like, you need to learn by sometimes things going wrong as well. And once you know these processes exist, then you're like, oh, there is a solution. So sometimes that's unfortunate reality, but sometimes organizations will have a cyber attack and that's the thing that prompts them, or they'll have, major, a plant gets hit by a tornado and now, or some major multi-day outage, and then suddenly they care about these things. But sometimes it takes that and the cultural memory of the business to get people to realize why it's important. But really, you do see this now, these network plants, and you see CIOs and CISOs taking them over, and you're like, well, what do we do with this? And you need good governance and control. You need good network security. You need, all of this. And then you even look at, the last thing I'll kind of harp on is like hard on-prem physical devices as storage. So like the standard was air gapping for a long time. And people were like, we've talked to companies before, we're like, we have all our code on a laptop, an intern stole it. And I'm like, well, where did the intern come from? Did you background check them? And the intern quit the next day. You're like, oh, well, are they back to China? So so you get in this interesting thing where it's like these CIOs and CISOs are coming in. They're like, whoa, what the hell is going on? And they're trying to figure out how to get good process in place.
Yep. Well, yeah, and all intriguing stuff that I know people are trying to wrap their minds around while they're also trying to keep their plants running. So it can be a bit of a challenge.
Yeah. Yeah. And that's a big thing too. I think that's worth calling out. And I use this phrase all the time. Someone told me it's gross, but I just don't think of it that visually when I say it's organ rejection. So like the biggest thing is, I don't think in a lot of cases when people are looking at this like organization-wide change management, they do enough work to understand the pain points and problems that people at the actual plant level
Yeah.
And so you see these kind of top-down initiatives kind of fail on not because anyone could explicitly reject it, but because you don't get buy-in. So like, can you give the right training at these levels and explain why these are a big deal and create the right incentives to kind of get people to do the right thing and view it as this is table stakes stuff, you know what I mean, that you need to just do as part of being a good engineer or good maintenance tech or whatever. Yeah.
Yeah. It's a great point. All right. Well, we are just about out of time. Before we go, I definitely want to hear, what are you looking at as far as the future goes? What are the big opportunities for you and for Copia Automation?
Yeah, I mean, we're kind of at a good stage where we're increasingly close to our kind of core platform, that backup and source control stuff being in a really healthy, mature state. You can always build additional vendor integrations, that sort of thing. We're starting to kind of get to those larger scale deployments and that sort of thing, seeing that really kind of scale up nicely. And so I think we're starting to turn the corner to really look at the rest of that industrial DevOps vision that I talked about. So really looking at automated testing, looking at deployment, looking at all those things. I mean, like, how do we actually deliver this vision to this space that we've been talking about? And how do you get that buy-in? And then that involves working really closely with our customers and, major opportunities that people that we've built relationships with, and kind of be like, well, how does this actually work in your operations? And really getting into, we were just talking about those cultural questions too, of like, okay, if you want to have automated testing, someone has to write the unit tests. How do you actually get people to do that? Or you want to have a deployment process. How do we actually get that? So building that sort of, actual understanding of like, well, how does this really work? And how is the industrial world obviously different than the IT world? And then how do we dig into those problems and really, make sure we're building a solution that works for people and is actually solving meaningful problems in their workflow, and then also through that, achieving this kind of vision of, let's lock down production, let's build good process, let's build blameless, postmortems and all this good stuff in the software space to really up-level our industrial productivity.
Excellent. Well, I think you guys are very well positioned. I'm no guru when it comes to industrial programming, but I think about my own experience in the past and the challenges we had. Now it's gotten even more complex and more, I think, demanding. You guys are positioned really well, both in the idea of, number one, going after that immense amount of downtime that coding errors and troubleshooting can bring. And we all know how expensive plant time is, but then the whole cybersecurity end, I know a lot of people just don't know which way to turn. So if you can bring some expertise there, I think people will be beating your door down.
Absolutely. Yeah. Well, yeah, we really appreciate the time. This is super fun and always happy to jam on this stuff. So thank you.
Well, great.
Yeah.
Thank you for being here. Adam Gluck with Copia Automation. I think we could have talked all day long, but you gave us a really good outline of what you guys are all about, and I wish you all the best in the future.
Yeah, absolutely. Have a great day. Enjoy your Friday. So
thank you.
Right.
And of course, as always, thanks to those of you in the audience. You're why we're here. This was immensely educational. I can't promise every show is going to be as educational as this one, as what Adam brought us, but they're all going to be educational. So come on back next week. We'll have another show for you. Thanks again for Manufacturing Talks. So long.
Thanks for tuning in to Manufacturing Talks with Jim Benoski. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.